Okay, I think I fixed it. We'll find out. Good. Yes. Oh, there's numbers down there. I should probably cut that video short on YouTube. I probably won't. Okay, so we got notes on parent functions and symmetry. We got a couple things to go through. I'm going to go through this pretty fast. We've seen most of it. Some of it might be a little bit new. So let's go over the first one. So it says the constant y equals 2. How the heck do you graph a constant? What kind of straight line? There's many straight lines. A horizontal straight line at the number 2. It says to mark clear points, but if it's just like this, you don't need to. Okay. Linear. It's a straight line. Very good, class. What kind of straight line? I see somebody doing this. Yeah, diagonal. It's got a slope of 1. Alright, now it starts to get a little bit, not trickier, but actually more thinking here. The quadratic, what shape is that? It's like a U, okay? Starting at 0, 0. You can just plug in points, right? You can make a little chart if you want. So an X, Y chart. I can do this for all of them, but you can plug in, get a 0, and you get a 0. What happens if you plug in a 1? Get 1 squared. What happens if you plug in a 2? 4. I'm going to run out of room after this. Plug in the 3, you're going to get a 9. But the quadratic is actually an even function. We'll talk about that a little more, which means it's symmetric over which axis? The y-axis. So this works as well because negative 1 squared is still 1. And we got this guy over here. So this is our parent function of a quadratic. Okay, the square root. Again, if you don't know, just start plugging in numbers. What number do you want to plug in first? 0, and, well, all of these functions, by the way, go through 0, 0. So 0, what happens when I plug in a 1? 1, plug in a, I wouldn't want to plug in a 2. Why? Why don't I want to plug in a 2? You get some weird number like 1.4 something, or a 3. What's the next number I should plug in? 4. I love the enthusiasm. 4. What's the next number I should plug in after that? A 9. Well, I don't have a 9 on here, so that's good enough for me. Why do I not plug in any negative numbers? It don't work, because square root of negative 1 actually gives me imaginary, and I can't graph imaginary. Well, on this piece of paper, I can't. Cubic. Because this is start where it gets a little bit on the weirder side of things. Goes through 0, 0. What happens if you plug in a 1? A 2. 8. Can we just pretend 8's all the way up here? We'll just call that 8. What if I plug in a negative 1? Negative 1. This is actually an odd function. So it's going to actually be some... it's symmetric in terms of, like, if you were to rotate your paper 180 degrees, it'd be the exact same picture. So that's what odd means. So the negative 2 is going to give me a negative 8. So it looks something like this. Cube root. What's the first number you want to plug in? 0, 0. Plug in a 1 and you get 1. What's the next number to plug in that's pretty? 8. So we'll just call 8 over here. And that's going to give me a value of 2. What if I plug in a negative 1? Because the square root, I couldn't do that. That gave me, like, bad things. What do you get? You get negative 1. So can I actually graph that? Awesome. And then what about negative 8? Does that give me something? Let's call that negative 8 right there. Yeah, negative 2. So actually, number 5 and 6, those are inverses of each other. Have you heard that word before? Good. Just means they reflect over the line y equals x. Absolute value. What shape is it? It's a V, okay. So it's got a slope of 1, right? What about in the other direction? It's got a slope of negative 1. It's a V. Plug in values if you didn't know this. Ooh, the rational. Remember seeing this in Algebra 2? Kind of, sort of, yeah. What's special about this one? Does this one have a 0 value? Because what's 1 over 0? It's undefined. It does not exist. Okay? Some of you are going like, yes, I did so well on that question. So we're going to draw what's called a vertical asymptote, because it can never equal 0. Can the answer ever spit out a 0? Like, is there any xi I can plug in to give me a 0 value? No, that's going to be our horizontal asymptote, which really only talks about end behavior, or horizontal asymptotes. It's maybe a little extra information for you, but did you know that functions can cross horizontal asymptotes? They can. Not vertical. It can't cross vertical. But you won't see that till a bit later. So, okay, I can't plug in a 0. Can I plug in a 1? Yeah. What does that give me? 1. What if I plug in a 2? You get a half. What's going to keep happening is I keep plugging in numbers that are bigger and bigger and bigger. Smaller and smaller. What if I plug in a 1/2? It gives me a 2. And same kind of deal, so it's going to look like this. And so make sure it hugs that asymptote right there. And this is actually also it's odd a function. And it's the inverse of itself. So we're going to plug in a -1, we get a -1. It's going to be the same story. Greatest integer function. Have you heard of that before, or is this brand new? Brand new? Okay, there's a couple different notations for greatest integer function. I think your textbook uses this, the double bars. I've also seen it where it does like the just the bottom of the brackets. I've seen it many different ways. Just different ways you'll see it. It will almost always tell you, hey, this is the greatest integer function. It won't just like say, hey, graph this, and then it'll just have that bar. It'll have to say greatest integer function because there's so many different ways for notation. I think on your worksheet you do it might not do that. So that's why I'm showing you this. So if you see this, and anytime near future, it just means greatest integer function. Okay, so greatest integer function is like when we always round. I don't always want to say down. I guess it is technically down. We always round down. So, like, 0 is 0, right? But then 0.5, rounding down from 0.5, get 0. 0.7, round down, 0. 0.999 is 0. You always round down. Always round down. What about a 1? It's a 1. Very good. 1.5. Okay, you get the idea. 7.5. 1. So it looks like this. So it's going to be like a whole 1 right here, and then it's going to equal 1, and then it's a whole right here at 2. This is also called a step function because it looks like a bunch of steps, like stairs. So always round down. So let's talk about our negatives. It's kind of weird if you're like, down. What's negative 0.5? Rounding down. By down, I mean like lower in the number chart. Would be -1, right? So it's going to be the same story here. Just going this way. I guess I'll just graph everything I can. So this is also a step function. Oh, there's more. Great. No, it's awesome. More learning. All right, exponential function. What does an exponential function look like? Well, I guess this is when a is I'm going to say when a is greater than 1, because you'll get different things. So when a is greater than 1, so let's pretend there's a 2, okay? So pretend a is a 2 real quick. What's 2 to the 0? Does any number to the 0 always equal 1? So it always goes through 1 right here. Always, always, always goes through that. And then from there, it just kind of depends. So, like, if it was a 2, the next 2 to the first would be 2. If it was a 3, it'd be 3 to the first, which is 3. It kind of depends what that a value is. So, it's going to just increase, and I'm just going to just draw some random one. It's going to go like this. This is just our general exponential function. In this case, I guess a is equal to 3, because it went through 1, 3. So that's just any exponential. If actually a was less than 1, then it would be decreasing. Like that the whole time. There's also some special information here too. Can the y ever equal 0 on this? Is it possible? No, it's impossible. So it's going to be an asymptote. Okay? And a logarithm is just the inverse of that, which means it reflects over y equals x. So you're going to get this, because no matter what, if you log base anything of 1 is always 0. So it's just the inverse of this, so it's going to look like this. Again, just some a value. And this one is going to have a vertical asymptote. I don't want to get too much into logs, because there'll be another day for that fun. Have you ever seen the Graph of Sine before? No? Yes? And algebra 2 they showed you? No? Who went home and Googled it one time? Good for you. Nobody. So this is what a sine graph looks like. Oh, physics? Alright, so you might have seen it for physics. And this actually goes on forever and ever and ever. It just keeps that same pattern over again. And then cosine is like this. And that pattern is going to keep repeating itself over and over and over and over and over again. Actually, if you notice, if I cover up this part of sine, actually then it starts to be a cosine graph. So sine and cosine graphs are the same if you just shift one. Okay, let's talk about some symmetry. So I've already used some of these words like even and odd, but let's look and see what they are. So even function is symmetric to the y-axis. So that's going to be, if you could just fold it over, then it's going to be visually, that's going to be even. How to tell if I just give you some function you have no clue how to graph? It's this guy right here. Plug in a negative x value. If it spits out the same exact function, then it's going to be even. Odd is I mentioned that when you can rotate it 180 degrees and the graph doesn't change. So that's when you plug in a negative x value and it actually gives you the complete opposite function. All the signs are different. And we'll do some lovely problems that pertain to that. So this is important. And it's possible for it to be neither. So if it doesn't fold over perfectly, if it doesn't rotate perfectly, then it's neither even or odd. So let's look at the first 14. Next to 14. So let's look at the first 14. Is that even, odd, or neither? Is it neither or neither? I don't know. Neither, neither. Whatever mood you're in. Okay, so 14, is that one even, odd, or neither? Even. It's even. Why is it even? Right, I can actually fold this over perfectly and then it'll fit, it'll match up. What about the next 14? Somebody's saying odd. Well, if I rotate it, is it the exact same picture I just had? Oh, it is, so it's odd. What, 15? Neither, neither. How do you even spell it? I before E? Wait, I before E? It doesn't work here for neither. Alright, so this gives you steps on how to figure everything out. So if it's even or odd or neither, neither, whatever, all you do is plug in a negative x value for it and see how it simplifies. Does it simplify to be the same thing? Even. Does it simplify to be the complete opposite? Odd. Does it simplify to be something that doesn't look like anything that we started with? Then it's neither. So for the first example right here, I'm going to plug in a negative x. So I'm going to do g of negative x equals negative x to the third minus negative x. This is just my plugging in step. If you notice, I wrap everything up in parentheses. I'm just trying to be nice, neat, and organized. So let's start simplifying this a little bit. What is negative x to the third? So that the third part doesn't change that negative, does it? So it stays negative. It's actually negative x to the third. And then a minus a negative gives me a. I'm done simplifying. Is this the same as the original? No. Is it the complete opposite? Are all the signs changed? Yes, all the signs change. I started with a positive x cubed. I now have a negative x cubed. I had a minus x, and I have a plus x. This is such an odd function. What's up? Zoom in. I wish I knew how to. Is there an easy way to zoom in? Just put it down like this. Yes, all the time video. Is that better? Okay. I've had some before where they have like zoom in buttons on them. I'm just trying to defend my thought process. Alright, example 2. What happens when you plug in a negative x? Give yourself just I'll give yourself like a 10-second head start, and then I'll follow along. So what is that squared to that negative x? Makes it positive, so it's actually x squared plus 1. So, did anything change? So it is and the last one, plug in a negative x. You're going to get 5 plus 3x. What do you think on this one? I'm going to say it's not odd. Some people might be thinking it's odd. Why is it not odd? The 5 didn't change at all. The 5 is still positive 5. And so not all the signs change, so this is going to be neither. Alright, last part. I'm just going to have 2 different colors just so it's easier for you to see. I'll do even in blue, and I'll do odd in maroon. Okay, so for number 16, how do I make it even? What's the definition of it? I just need to make it symmetrical across the y-axis. So I'm just going to I'm going to count over to make sure I'm doing everything correctly. I don't know, that looks like that's 1, 2, 3. It looks like it's this in blue. Give or take. So that's even. How the heck would I make this thing odd? Just turn that bad boy around and match it. So I'm trying to remember exactly where it was. I think it was like over here, and then I think it's like over here. go. Good thing I have to draw this on the other side. That would just look like a cursive X. Okay, 17. I'm going to kind of go through this a little bit faster. So it looks like it's just a curve. It tops out about right there and then goes right there, it looks like. And I turn it around. Tops out about there, goes about there. Anybody getting dizzy yet? Yes. I'm sorry. This one I'm going to need just a little more of a guessing for. Something like that. And then you turn it around. Something like that. So you have two more yellow sheets. The one yellow sheet, I'm not going to go over it. It says 1.3 notes, graphs of functions. It goes over that step function, so you can kind of see what the heck it looks like. So that kind of explains the step function more. It actually just goes through like everything that we did. So you can keep that in your back pocket or whatever. I don't really care. Let's take out the one that is a chart. The chart one. I'm just going to go through this part real fast because we've already did most of this. So the first one, what's the name of y equals x? It's linear. Already did the graph. What's the domain? Who remembers what domain means? I know it's been a whole summer. Domain are the x's, by the way. Domain's the x, so how far left does it go, how far right does it go? Well, it goes on forever. So I'm going to do negative infinity to infinity. Have you seen this before, the parentheses? Okay, just making sure you get that. You know that. The range is the same thing, from how low to how high. Critical attributes, I don't really think I have any critical attributes here. Is it even, odd, or neither? It's odd. Next one, y equals x squared. That is a quadratic. It's definitely a u. The domain, how, left to right, it's not limited, so it goes from negative infinity to infinity. The range is a little different, though. How low does this one go? To 0. It's where the vertex is in our parent function. It touches it, so that's why we have a bracket. Is this odd, even, or neither? Even. Y equals root x. That is a square or radical. I don't know what we want to call it. Let's just call it a square root. Looks like that guy right there. The domain is 0 to infinity, and then the range is 0 to infinity. odd, even, or neither? Neither. You can't even plug in a negative into that function. 1 over x. That is a rational. Your best little. Let's look at one of these guys. This is going to go from negative infinity to 0. Union 0 to infinity. That just means it can equal everything except for 0 for the x's. And the y's is the same story, just for the range. Odd, even, neither. It's odd. Next one is exponential. Domain is from negative infinity to infinity, and the range does not touch 0, and then goes to infinity. What happens when I make that x negative? How does it change? It happens when I plug in a negative into an exponent. It becomes a fraction. Thank you for saying that. I taught Algebra 2 Lab last year. They had to be like, it makes it negative. And they're like, no. Go back to your real teacher. I didn't really say that to them. So this is neither. Next one, this is a logarithm. Oh, we're really testing my spelling skills here. Hopefully I saw it somewhere. Oh, good. I see it. This is a logarithmic, actually I'll call it logarithmic graph. The domain and range are just flipped from the exponential, because they're inverses of each other. And this is neither. What's this next one called? Cubic. Am I going too fast, by the way? Too slow? Just right. Okay. Looks like that guy right there. Domain and range are all real numbers, so negative infinity to infinity. And this one's odd. This one is just a cube root. So this one is just like the cubic, just inverses, so flip the domain and range, which happens to be everything. And this is also odd. Alright. Got the absolute value. Just looks like a V. Domain negative infinity to infinity. Range is 0. I heard someone say it. 0 to infinity. Odd or even or neither? Oh, like the only other even one we have. By definition, absolute value makes any parent function even. Because plug in a negative x into it. Boom. And then the last one, that's my greatest integer. Looks like this guy. I'm not going to put the dots on the left-hand side. Looks like that. This has got like a weird domain and range. Well, the domain's not weird. The domain is it touches all the values. The range is it's not all of them because you can't have it equal like a half. It's just actually it's all integers. There's a fancy way to write that, but I don't. You would just use the integer symbol, which is a z. Odd, even, or neither. Okay, if I flip this around, is that the same picture? Remember how I told you I'm gonna have all the dots are the open circles on the right? Are they open on the right when I flip it over? No, so it's actually gonna be neither.